Hi everybody, it's John Pushkar, and I'm here again today with another episode out of the fuels and combustion equipment world that hopefully helps to keep you safe. Today is episode 4 of the Captain of Obvious Fired Equipment Hazards series, and today we're going to talk mostly about fuel train and component issues. Over the last 40 years, I've developed and led fuels and combustion equipment safety programs for the largest manufacturers in the world. Today, I'm bringing you knowledge, insights, and best practices about fired equipment and natural gas safety. Over the next few minutes, you'll get the kind of practical, real-life explanations that I've become known for. So they don't get much more obvious than this, do they? Here's a really big gas valve with a really big gas valve handle, and clearly the handle's bent. This valve's obviously seized in position or takes way too much torque to operate. Neither one is good for you in the case of an emergency when just anyone would need to reach up and get that valve closed in a hurry. This one too is very obvious to me, at least, because I know that this is a lubricated plug valve. What you're seeing that's all discolored and rusty is called the button head fitting. This is where sealant gets injected. Lubricated plug valves have no metal to metal or metal to seal contact within them. There's just a plug with an air gap around it and then the body of the valve. It's only a special sealant that gets injected through this fitting that actually makes the valve function and be able to isolate a fluid in a section of pipe. If you see a button head fitting that's this corroded or painted over, it means that obviously no one's been servicing this on an annual basis as is required by valve manufacturers and in some of the equipment codes like NFPA 86. If you don't keep these things regularly serviced, it means they'll seize in position like the first valve we saw, or it means they'll leak through when they're in the closed position. And how about this one? Again, it doesn't get more obvious than this. I know I've probably said that before, but here's a button head fitting that's actually been sheared. Yes, you can break valves. You can get a big enough pipe wrench, a big enough valve handle, and you could actually physically destroy a valve. If you do this and break the casting, I don't know that you can run fast enough because you'll have full line pressure coming into the room. The button head fitting for this one was actually found on the ground below this valve. Hopefully, after watching this video, you'll understand that lubricated plug valves need serviced regularly and you'll never have to encounter this situation. Ah yes, paint. What a wonderful thing. Yes, paint fights corrosion, but paint over lubricated plug valves or any valves with mechanisms that need to move one with respect to the other is never a good thing. It's obvious to me here, this has been painted over so many times, you're never going to get it to move. Let's move on to some other things you're likely to encounter in a fuel train. A simple quick look-see here identifies that although there is something that looks like a dirt leg, there's no strainer here. And if you look closely at the dirt leg, drip leg, sediment trap, the vertical piece of piping that projects down from the T after the gas takes a 90-degree turn, you'll see that frankly it's not installed properly, it's not designed properly. NFPA 54, the National Fuel Gas Code, well, it says that drip legs have to be at least 3 times in length whatever the diameter of the pipe is, and the diameter of the pipe cannot be reduced. Here you can see we obviously don't have enough depth. You can also see that there's no strainer installed. So if we do carry some contaminants down in the pipe and they do make that 90-degree turn, they're likely to end up in the regulator, which is not a place we want them to be. And if they get past the regulator, they can end up between the stem and the seat of one of our safety shutoff valves. This is really a big problem because if we cycle the equipment off and we've got some debris in the stem and the seat interface there, we'll leak fuel through possibly into the firebox while the equipment is down. And when that happens, there could be a really big, catastrophic, nasty surprise when somebody goes to start the equipment. Oh, come on, you say. Is there really debris in gas lines? Well, this is actually a valve I'm holding in my hand, and this is the inlet to the valve, and you could see all that stuff that's stuffed in there. This is one of dozens of valves like this and filtering components that I've held in my hands during my career that is just stuffed with debris. You wouldn't believe what's in gas lines. There's rust, there's mill scale, there's welding slag, and debris from when people prepare pipes to be welded. I took that valve and actually tapped it on this piece of structural steel here next to this furnace at this industrial plant, and look at the piles of stuff that was in there. I took a quick shot here of a pipe fitter getting ready to prepare a section of gas line to be welded. Here you could see he just finished torch cutting this piece of pipe. Look at all the stuff inside. Do you really think that all gets out? Not in the real world. When it comes to gas piping, building it clean is a phrase that should be tattooed on everybody's forehead. This is a job that was going into a power plant that was going to service gas turbines. The need for clean gas in gas turbines, it's ultra critical. You can see they've got these little covers over every section of pipe that's being stored waiting to be installed. Not a bad idea, even for run-of-the-mill industrial gas piping projects. The third obvious fuel train issue I'd like to point out to you has to do with venting. Lots of people don't understand how to apply venting systems correctly on the components of fuel trains. It's a little confusing in some of the codes and standards as well. Some of the general rules, for example, are that whatever size fitting you're given on a component, you can't reduce that in size. So for example, on this regulator, if it's a 3/4 or a 1-inch outlet, that's the size pipe you must use from that device, and you can only go up from there, you can't go down. And main regulators like this, they shouldn't be tied into anything else. The bleeds from double block and bleeds on a fuel train should not be tied into anything else. If you do have vents from pressure switches, they can be combined, but you have to increase the outlet of any two lines that you combine by 50% of the largest of the two lines that you combine. If you do run into a situation where you've got some vent piping issues, you're much better off to try to get ventless pressure switches or vent limiting orifices that a manufacturer might provide for pilot regulators. Much simpler than repiping the entire thing. And this example shows many of the same mistakes. You can see that the main regulator here is tied in with pressure switches and even a vent from the pilot regulator system. Obvious issue number 4? Well, it's best observed at the termination of vent outlets like we've been looking at. Usually these are out the sidewall of a building or accessible from a roof. In this particular case, you can see on the right of my picture that there's an insect nest in the end termination of this vent. Insects are attracted to mercaptan, the odorizing chemical that's used in natural gas systems. So it's kind of a favorite place for them to build nests. Be careful when checking them because sometimes they'll actually fly out of there, many of them. There's supposed to be vent termination protection, and the discharges from these vents are supposed to be turned down to protect you from getting rainwater into the system. Obvious issue number 5, components that aren't rated for the pressure that they're handling. Well, who would have ever thought there's actually ball valves out there rated for only a half pound? You've got to remember that all fuel train components must be protected from or rated for whatever pressure you would see if the closest upstream regulator were to fail. Here's another one. Even though this is a 2.5-inch pipe-sized ball valve, if you look carefully and you look at the lower writing under the word Italy, it also says 1/2 PSIG. And it's not just valves you need to be concerned with, but you need to be concerned with the ratings of the pressure switches, the safety shutoff valves, and any other components that you would have in that fuel train system. If you're watching all of the Obvious Hazard series, hopefully you've seen number 1, where we've talked about control panels and we've talked about recalls and obsolete devices. Well, believe it or not, there are recalls that have been issued, which you can find on the Consumer Product Safety Division website, for even ball valves. Here's an example of one that has found to have defects in it, and this particular brand and model has been recalled. Another obvious issue. You walk up to a valve actuator and you see this oil all over it, and it's a gas-fired device. Where'd that oil come from? Well, it's because these are hydraulic actuators. So hydraulic implies there's a hydraulic fluid, and the top part of this actuator is actually a reservoir of that fluid. Over time, and if conditions are right, this can leak out and put you in a situation where the actuator will no longer work or no longer work properly. Also, while you're at it and looking at actuators, grab them and give them a little wiggle, see if they'll shake. There's 2 90-degree opposed set screws that hold this style of actuator to the top of the valve. Sometimes they don't get installed correctly, sometimes they're loose, and again, when that happens, we can be in a situation where if the valve's called upon to close, the actuator's not installed correctly, it won't get closed. And I'm sure it's obvious to you, and I don't need to explain it, but if the actuator isn't installed correctly and actually falls off or can't fully stroke the valve, you might be in a condition where you have a flame out and you can't shut the gas off. That could have a very catastrophic ending. And number 7 here, never a good idea to have fittings on a fuel train that don't have caps or plugs on them. Imagine if someone were to walk by this ball valve and actually kind of bump into it and partially open it. We'd have full line pressure leaking out into the space. So take a look, see if you've got plugs missing, make sure they get installed. Number 8, you need to be looking for places people might have used low melting point soldered copper. NFPA 54 gives requirements for what materials can be used in fuel trains, and low melting point soldered copper, like you might use in a regular water plumbing system, is not allowed. I hope you can understand. I hope it's obvious to you that if temperatures were to be elevated, it could literally fall apart. When you use copper like this, you have to use what people refer to as brazing methods, high melting point soldering materials, to actually make these connections. Take a good hard look where anything's bolted together, flanged connections or flanged components. If you don't have at least 1.5 or 2 threads protruding through that nut, it means that you do not have the design clamping force that bolted connection was designed to provide. This means you're more likely to have leaks, or the thing is more likely to possibly loosen up and come apart over time. Neither of those, of course, is a good thing. Number 10, I hope it's obvious to you that we don't want to have gas leaks. This happened to be at a plant I won't mention that's out of the United States. I walked by and I saw a flame where I didn't think there should be a flame, and sure enough, it was a leak on the outside of this Bell annealing furnace. I hope the gas leaks you might find are never this obvious. How would you be expected to find a gas leak? With a gas detector, of course, not with your nose, not with a lighter. Gas detectors these days are relatively inexpensive. Anyone can be trained to use them. It should be a regular thing. Obviously, I'm showing you here evidence why you don't want to use a lighter. Is the gas piping obviously damaged? Is it bent? Has somebody run into it with a forklift? Are there pipe hangers missing? Are there pipe hangers up there, but the pipe's still swaying in the breeze, or there's no contact between the hanger and the pipe? All of these are obvious circumstances where you need to take action. This may not be obvious to you, but it will be in just a few seconds. What you're seeing on the left of my picture are test plugs for a safety shutoff valve, one before the stem to seat connection and one downstream of the stem to seat connection. And if you look to the right of my picture, there's a close-up indicating that this plug, it's likely never been out in the life of this valve. If this plug's never been out, it means that the annually required valve seat leakage testing is not being performed. Remember all that crud I showed you that is quite often in fuel trains? It means that this valve could have crud between its stem and its seat, and when it's actually in the closed position, it may not really be holding gas back. Don't you think this is something you'd like to know on your terms and not when a firebox is full of fuel and you have some type of catastrophic explosion? Here's some additional shots of the same situation. You can see in the upper right, it's been painted over forever. Those have never been out. And likewise on the lower right, more of these that have never been out. This is quite a common occurrence, and it's a very obvious thing you could find. If you want to know more about valve seat leakage testing, I've got modules at the Prescient Technical Services online school that can tell you all about it. Number 13, I love to study linkage systems. I like to look at them very close because looking at linkage systems, that's been very fertile hunting grounds for me throughout my career to find some obvious, very scary things. Like, look at this linkage rod holder. It's barely holding on to just the tip of this linkage. If this continues to slip out, we could have catastrophic consequences. What about here? Looks like this used to be in a completely different position. Did someone move it on purpose, or did it just slip? Why all these witness marks on this piece of linkage rod? Usually once someone properly commissions a linkage system, there's no reason to ever move it in the life of that equipment. It's especially a problem if it appears obvious that large changes have been made. I would want to stop here, take a good hard look at what the flame looks like, and start talking to people about who made these changes and why. And a very simple change you can make costs you nothing but a few seconds of your time, and it'll make changes in linkage positions very obvious. That's called match marking. Just take a Sharpie marker, mark the linkage that's to be driven and the piece that drives it. Mark on both sides of linkage holders and clamps, and if any of those move one respect to the other, you'll see it in an instant. It'll be very obvious to you. And no episode on obvious fuel train issues would be complete if we didn't spend a couple of minutes talking about optical flame detectors. Because you see, there are self-checking flame detectors and not self-checking or non-self-checking flame detectors. The upper right-hand picture there, that's a non-self-checking detector, a standard detector. The one below it is a self-checking detector. The non-self-checking detectors, the standard ones, upper right, relatively inexpensive and simpler to install than their more expensive cousin on the right. However, Honeywell, in their instructions for the one on the right, the non-self-checking, less expensive one, will tell you that they're only meant for circumstances where the burner cycles at least once every 24 hours. And a cycle is a complete on and off of the burner. So if you have things that run continuously for days at a time, maybe weeks, maybe months, they should have self-checking detectors like I'm showing you in the lower right-hand corner. And why do we care? Why is it important? It's important because it's been discovered that the most prolific, most common failure mode of non-self-checking detectors is to be stuck on thinking there's a flame when actually there's not a flame. And if that thing sticks on and there's no flame, it means it'll send a signal to hold the gas valves wide open and continue to send gas to the burner. Well, sending gas to a firebox or a burner system when there's no flame only leads to catastrophic events. You accumulate that fuel-air mixture, it lights off at once, and metal goes flying. Not a very pleasant thing. So take a look. Should be obvious whether or not you have the right style of detector installed. And last but not least, optical detectors all have maximum ambient temperatures and conditions upon which you get the longest expected useful life out of them. For the type that I'm showing you here, it's about 210 degrees. In some applications, in some circumstances, cooling air is provided. Like you see the little instrument airline there, you see the magnehelic gauge. That magnehelic gauge, that actually is indicating that there's flow of cooling air for that particular optical detector. Now, some people put gauges in like that, some don't. Sometimes there's just a little valve. But if you have a system that requires cooling air, make sure that it's on. Make sure that it's functional. It should be an obvious thing for you to be able to check. Hi, it's John Pushkar. I hope you found this episode useful. If you'd like to know about more ways that I can help, you can check out my website at www.prescientts.com. There you'll find information about the Prescient Technical Services Online School, my book, Fuels and Combustion System Safety, What You Don't Know Can Kill You, and also about some of the consulting projects that I've been providing to clients for the past 40 years. Things like implementing inspection and testing programs on a corporate enterprise-wide level, things like reviewing and commenting on capital equipment purchases that involve combustion equipment, and even being a legal expert if things go really wrong. Once again, thank you for attending, and remember, be safe out there. The life you save, it just might be yours.